Hello. Hello. Welcome to D9 of AOC. Well, today is a day. Today is the day where I'm going to have to start this off with a bit of a rant because I am done with this particular thing happening. First, before I fly off the handle here, let me reiterate, let me just reassure people that I'm very much aware that these people make these rooms weeks in advance, sometimes months in advance. You can see that in some of the VM names. But I've seen the same thing pop up several times through last year's AOC, and I gave feedback about it then, and I've mentioned it this week as well to the content manager that I've spoken to a few times. They are very much part of this, and I'm sure they've sent my feedback along to the right teams. But I'm going to essentially provide a couple of arguments for why I say what I say, because when I opened this task today, pretty much my first reaction was, you gotta be f***ing kidding me, is this f***ing happening again? I'm really getting f***ing tired of this now. Basically, the setup is the following. We have a VM, we have a virtual machine that you spin up. Let's do that actually. There. We have a VM that you spin up. It shows up in a split screen, and and you have RDP access. You are able to RDP, but it's severely limited. You're not allowed to send files back and forth over the RDP connection, for example. At least I couldn't get that to work by just using the regular way. Normally, you can just copy paste files from RDP host to guest. That doesn't work. You can supply yourself your own hard drive as a local source in the RDP connection. That doesn't work either. So you pretty much just get given the VM, and that is what you get. And I sort of compare this to these computerized exam centers for various certifications that just give you a lockdown system that you do your exam on, with all the consequences thereof. One of which is, of course, accessibility is non-existent. On both the Linux and Windows machines, for different reasons, there's no audio. So any screen reader I would be able to run on them wouldn't be able to actually output any sound, which is kind of what they're known for. So that's a problem. There's no access to the internet, so you can't actually smuggle in files either. I couldn't sneak a screen reader on there and then set up a remote connection, which is what I would have tried next if I had this possibility. And I get it. I understand that there is a standard template. I understand that there are rules, and I understand that these people need to cover their asses. But this is just not doable in the way it's currently being done, and I'll tell you why. Basically, what's happening here is really cool tasks are being developed. I really love what they've done today. We get to do some malware reverse engineering, basically. We get to do some decompiling. We get to sort of maze around in a bunch of code, which is well explained, and you can just learn a little bit about how that all works. Except some people can't, because they can't see the VM at all. Some people can't because it's a super tiny, stupidly small font. And you can't change that because it's one machine that can't do anything with. It's just sort of hanging out there, and you can interact with it in some ways, but not in others. Accessibility is therefore problematic for a lot of people. I've seen a lot of people complain about the font size in the Discord and on videos as well. It's annoying, which is why I usually bring up the argument of let people bring their own mother tools so they can just sort of work in a setup that works for them. And I ranted about this a little bit on Mastodon, so I'm not going to repeat it here, but basically I said let people just use their setup that they're familiar and comfortable with. That is also what you do in the real world. Obviously there are times when you can't, when you have to work. You know, I know what living off the land means, obviously, and that's very much a given. But right now what we're doing is we're teaching people. And that teaching is really being inhibited and impaired by how these teachings are being delivered. In this case, we have a malware sample, a defanged malware sample, mind you, that is locked in a folder within the VM that you then have to use a tool on. This tool is open source, it's free, you can just download it yourself if you want to. The malware sample is harmless because the URLs for the C command and control servers are non-existent. So there is literally zero reason to not just give a link that says, hey, if you want to do this in the VM, that's cool. That's what TryHackMe is known for. But you can also just download it and not do that. It would not cost anything. It would not be a problem. It would help a lot of people get a lot of more work done, and it would make me less grumpy. But that's not what they've done today. So I'm going to make a point. I'm going to start this tool in the remote machine. However long it's going to take, I'm going to do it. And I'm going to open up the folder that we need. And then I'm going to do the exact same thing with a random C# program that I downloaded off the internet on my own machine. And show off how much faster that is. That's what we're doing. And then we're doing the actual task. Because y'all made me mad. What I want to do first while I do that and while I set this up is shout out Husky Hacks on YouTube. He's been doing the walkthrough for this room today. Phenomenal speaker on YouTube, I must say. I really enjoy his content. He helped me out a couple times last year when I did AOC by myself. And yeah, phenomenal walkthrough. He has a practical malware and triage course on ZTM Academy. So if this is something you like to do, I'd definitely check that out. I haven't seen if that's quite as approachable and accessible as his YouTube content is. I'm assuming it would be. But for sure, yeah, he's the man. You send him a thank you note before I started recording this video. But yeah, okay, let's just see where we're at, because I actually don't know. Let's see. Where's the graphic? Oh, cute. Hang on. I'm already annoyed. Okay, so... Whoa. We need to try somehow to get a remote shell going. So let's go do that real quick. What's the IP? The IP is 10.10.93.18. So let's just pop that into our remote desktop application. Boom. Boom. Everything else is still the same. Show options. Username is analyst. I'll switch over to the remote session in just a minute with the with OBS so you can see it. Okay. Huh? Yeah, don't ask again. Connect. What is the password? AOC 2023. I'm pretty sure this VM and the one from yesterday are made by the same person because the credentials are exactly the same and there's some overlap, which is cool. I'm actually going to just like lower the music a tiny bit so I'm not having to shout so much. There we go. Okay. So OBS. We're gonna switch the thing over. Always check if I'm not streaming by mistake, because I do that on Twitch as well, if people are curious. Let's see. Twitch. Behold. The remote session. Alright, so we now somehow need to figure out where the tool is. Need to OCR the screen. Let's see how tedious that is. Okay. Oh, there we go. We got tools. DN spy. That's where it is. We just double clicked it. Let's hope it actually opens up. We never really know because we can't see what we're doing because I'm not gonna start again. I'm gonna start again. I promise I will not rant more. All right, let's see. Did it come up? I can't really tell if it did. The NVDA speech viewer is in the way again, because I can't really see if we actually managed to do it. It doesn't look like we did though. So that's a first start. That's wonderful. Let's try it one more time. Oh, my bad. There. Did that do it? If not, well, that's it. We're locked out. We can't do the video. Goodbye. Have a good day now. Yeah, I can't actually tell. So what I was going to do was painstakingly find the file menu and then open, and then another thing, and then we find the tool, and it takes forever. Now, let's not do that. Instead, let's just actually do this on my machine, where I have also downloaded this tool. I'm now opening it. Took me 2 seconds to do. In a second, I'm going to put it on your screens. Of course, when I'm trying to make a point and be fast, it won't let me be fast. There it goes. Okay, so open it up. There it goes. It's loading. It's still loading. It's not a very fast opening tool. There it is. I'm going to put OBS on it. Whoosh. Up. There it is. We go to the thing. We open it up. You can now see my desktop and whatever I have in here. I open up, what do we have? We have a Crunchyroll downloader that I grabbed off GitHub. We're opening it up, and there it is. Took us not even a minute to do. You can now look through this. This application isn't super accessible, but it works okay. We have to OCR what we're on, but this is the... There we go. So basically what's happening here is... because of a bug in how the way the .NET framework works, we get class names instead of strings that are actually in this. And I'll need to go on GitHub and maybe fix that. And this tool that they're having, the incarnation that they're using, is not even really maintained anymore. You need to go to a fork now. dnspy-ex if you're curious. But yeah, this is all the stuff. This is what they're going to tell us about. All the things. And you can get the code and all the things. And we're going to go through that in a minute. But that's how fast it was. And if I don't want to even use this tool, I can also just go to a command line window. And we'll switch over to that. Up. Yeah, we can just go up here. Where's the command line? Here it is. Whoosh. We go into the folder. It's super simple. There it is. I put it in DNSPy because that makes perfect sense. Yep, that's the one. And we just do ./dnspy.console. We want the Crunchyroll downloader. And we want to put that in source. And there it goes. And voila. There's all the code. Was that really so hard? To just give me a tool, give me a thing, to just a zip file, and with a password on it if you must be curious or careful. And I could have just done this. And I wouldn't have had a need to rumble or grumble or rant or scream and shout. This would have worked fine. But no, we're not doing that. So I'm going to have to rely on third-party people to not be able to do the puzzles myself and make videos about how I couldn't do it myself, which is not something I enjoy doing. Let me put it this way. I like doing videos of these challenges when I know I can do them. And I like doing videos when I know I would technically be able to do them if I was accessible enough to do so. Right now, I don't enjoy making this video. I don't enjoy yelling at people. I don't enjoy ranting for literally 10 minutes before we even get to the stupid task. But all right, that's where we've gotten me. Day 9. Let's see where I am at the 24-day mark. Let me actually start reading this stuff because there's a lot of text to go over. We're not going to read all of it because it is pretty much a programming primer is like in this whole thing, and you can Google that yourself if you want to know. But yeah, we'll go over the salient bits, as it were. Let's see here. We have the diagonal machine here. But yeah, that's fine. And here is task number what is it? 15? Yeah, 15. Day 9, malware analysis. She sells C# shells by the C2 shore. Well, thank you for making me say that. The story. Task banner for day 9. Still don't know what those mean. Okay, there's a video by Husky Hacks, like I said. And then here we have the story. Having retrieved the deleted version of the malware that allows Tracy McGreedy to control elves remotely, Forensic McBlue and his team have started investigating to stop the mind control incident. Wait, mind control incident? We missed a whole bunch of story. I think there was like a whole bunch of animations yesterday. I think there's a lot of text balloons in that. Because the whole mind control thing is new to me. I guess we missed some alt texts. This is what happens. You exclude people. Do I have to go on? All right. They are now planning to take revenge by analyzing the C2's backend infrastructure. C2 stands for Command and Control. Based on the malware's source code. Learning objectives. In this task, we will focus on the following vital learnings to assist Forensic McBlue in analyzing the retrieved malware sample. So honestly, I will say this is quite a bit less beginnery than all the other things we've done so far. There's a lot of programming concepts coming up here. You need some C# knowledge. They give you some C#. They give you a primer, for sure. There's like a whole spoilered button that teaches you all the things. Which, fair enough. But it's quite a bit more like cognitively like difficult than the other tasks have been. Maybe with the exception of what was happening with the with the game. The buffer overflow is also pretty tough for some people to grasp, as it were. We couldn't really do much with that one, but yeah. I know there's still people looking for the ghost even today. We didn't even bother because it's in the game and no. But yeah. Okay. The foundations of analyzing malware samples safely. Yeah, that's certainly important. The fundamentals of .NET binaries. The DNSpy tool for decompiling malware samples written in .NET. Building an essential methodology for analyzing malware source code. Okay, that's it. The first section is what I'm going to read out in full because it is really important. Malware Handling 101. Forensic McBlue image. Warning! Exclamation point. Handling a malware sample is dangerous. Always take precautions during your analysis. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, or compromise the security and functionality of computer systems. Given this, we will again introduce the concept of malware sandboxing. A sandbox is like a pretend computer setup that acts like a real one. It's a safe place for experts to test malware and see how it behaves without any danger. Having a sandbox environment is essential when conducting malware analysis because it stops experts from running malware on their actual work computers, which could be risky and harmful. A typical environment setup of a malware sandbox contains the following. Network controls. Sandboxes often have network controls to limit and monitor the network traffic the malware generates. This also prevents the propagation of malware in any other assets. Virtualization. Many sandboxes use technologies like VMware, VirtualBox, or Hyper-V to run the malware in a controlled, isolated environment. This allows for easy snapshots, resets, and disposal after the analysis. Monitoring and logging. Sandboxes record detailed logs of the malware's activities, including system interactions, network traffic, and file modification. These logs are invaluable for analyzing and understanding the malware's behavior. Connecting to the machine. Before moving forward, review the questions in the connection card shown below. Okay, it says day 9, what should I do today? Connection card details, start the target machine. A split screen view, iframe, is available, and credentials are provided for RDP, VNC, or SSH directly into the machine. Yeah, that's RDP, just like yesterday. And that's also RD pointless for us in this particular case. Start the attached virtual machine by clicking the Start Machine button at the top right of this. Yeah, we've seen this before. Machine will start in a split screen view. If a virtual machine isn't visible, use the load. Yeah, okay. I think pretty much they just copy paste that in every task. Alright, top right. The VM will serve as your sandbox, but we won't actually be executing or detonating the malware, as we'll be focusing on conducting a static analysis. Even if you did, friends, you wouldn't have to worry about anything, because this VM actually doesn't talk to the internet. Look, believe me, I tried. It will not ping, it will not go to websites, it's not going to be any problems if you were to run it. Even if you didn't defang it first. This malware does nothing, and even if it did, the URLs don't exist. Okay. You can also use these credentials to access the machine via RDP. Yeah, so the username is analyst. The password is AOC 2023 exclamation point, like yesterday, and the IP address is 10.10.93.18 in my case. Optional, building from the VM on day 8, you can use the password advent of cyber 2023 in underscore day 9 exclamation point 1 exclamation point to unlock the zip archive juicytomatoy.zip and access the malware sample for today's decompilation exercise. However, for your convenience, the VM on this task will have the defanged malware sample placed in the artifacts folder on the desktop. And right here it should say, or you can click this link to download it to your own machine so you don't have to work with our cramped infrastructure that doesn't do what you want. Alright. Like I said, that was just Hyde coming out for a second there. I'm back to Gecko now. Mr. Gecko. No, check the intro to malware analysis room as a refresher on static analysis concept. I don't think you're meant to be using other rooms to supplement your own in Advent of Cyber, but I didn't really read the rules on that. Introduction to .NET compiled binaries. Again, this is also important, so I will read this out loud as well. The more programming bits, I'll probably have the computer read because, you know, we have been doing that theme where more cybery things are the computer's thing to read and everything else isn't. This is still pretty theoretical, so I will read this. I'll be nice. .NET binaries are compiled files containing code written in languages compatible with the .NET framework, such as C#, VB.NET, F#, or Managed C++. These binaries are executable files with the .exe extension, or dynamic linked libraries, DLLs, with the .dll extension. They can also be assemblies that contain multiple types and resources. Compared to other programming languages like C or C++, languages that use .NET, such as C#, don't directly translate the code into machine code after compilation. Instead, they use an intermediate language, IL, like a pseudocode, and translate it into native machine code during runtime via a Common Language Runtime, CLR, environment. This may be a bit overwhelming. That phrase, like this is a drinking game for this video. Every time you see the word overwhelming, take a shot. If you do that, I'll be drunk by the end of the video. This may be a bit overwhelming. In simpler terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instructions, low level, Meanwhile, a C# binary can be decompiled and its source code retrieved, since the intermediate language contains metadata that can be reconverted to its source code form. Basic C# programming. Based on the ELV's initial checks, it has been discovered that the retrieved malware is written in C#. So let's quickly discuss C#'s code syntax to analyze the sample effectively. We're not going to be doing that. You can skip this section if you are already familiar with C#. Else, click the View Code button below. So this is something I will give them. There is a lot of code samples in this particular task, and this is why I'm not going to read everything. But there are code samples for most things. Not enough to get you the answers, but enough to actually sort of see what they're doing. Which is good. I like that they've done that, and definitely kudos for that, because otherwise you would have like even less idea of what was happening. So the majority of the code that we're actually interested in is in this task's text, and you can look at them, and that's good. Because you can follow the explanations, you can learn from them, you just can't do the actual questions. I already did the questions for this task, because otherwise we wouldn't have gotten anywhere with them. But, yeah, so essentially we have this whole primer, and I think after that, don't worry if you find these code snippets a little overwhelming, that's number 2. Once we start analyzing the malware, the following sections will be much easier to understand. Okay. Yeah, there's the C primer. According to Forensic McBlue, retrieved malware sample is presumed to be related to the organization's remote mind control over C2 incident. So to build the right mindset in solving this case, let's look at the run-through below about malware with C# capabilities, C2 capabilities. C2, or command and control, refers to a centralized system or infrastructure that malicious actors use to remotely manage and control compromised devices or systems. It serves as a channel through which attackers issue commands to compromised entities, enabling them to carry out various activities such as data theft, surveillance, or further malware propagation. There's a diagram here that just has the alt text of C2 connection diagram, which is kind of pointless. I'll sort of go over it real quick. Essentially, the way this works is once a malware has been dropped on the target, it's going to at some point ping home, telling the command and control server that they're there and that they exist and that they're alive, basically. And then the way this one works is the command and control server has a URL that the agent, as it were, can go to, and if there is like anything on that URL, if that URL returns a response, that'll be the instructions for the for that particular box to go to, or for all of them. I don't think there's an ID for the boxes in this particular example, but in this case, it would be, for example, run this command, or go to sleep, or download this other malware and put it in the app data folder. And that happens every so many seconds. In this case, 15 seconds. Every 15 seconds it checks. It says, hey, I'm alive. What am I supposed to do now? And there's either nothing, in which case it goes to sleep, or there's like a couple of commands, and we'll go over that in a minute, that it can give from that URL. And yeah, that's what it does. Basically, the whole malware, that's why I'm not going to go through all these sections. Going to summarize how it works. Basically, the malware is a main function that calls a couple of other functions. It can retrieve from a URL, it can post to a URL, it can encrypt and decrypt information. It uses AES for that, and it uses an MD base 64 conversion as well. And it can I believe the implant function is a different function where it just downloads the response off of a certain URL and then decrypts it, which is a different kind of malware, basically. That is what the next X amount of pages of text will tell us. Seeing C2 traffic means that malware has already been executed inside the victim machine, as detailed in the diagram above. In terms of cyber kill chain stages, the attacker has successfully crafted and delivered the malware to the target and potentially moves laterally inside the network to achieve its objectives. Again, I don't think a lot of the beginners will know what the kill chain even is. So I'm kind of interested in the difficulty spike and like prior knowledge spike that we're seeing here, but okay. To expound further, please don't. Malware with C2 capabilities typically exhibits the following behaviors. HTTP requests, there's an explanation. Command execution, so you can run commands on your system. Sleep or delay, just sort of hangs out, not doing anything, so it doesn't get detected. I'm very much paraphrasing, obviously. We'll try to find these functionalities in the following section. Decompiling malware samples with DNSpy. This is the last section I'll really read, because everything else is pretty much an expoundation of what I just said. And with code samples, if that's something you're interested in, you can go look at it yourself. It's free, so why not? Decompiling malware samples with DNSpy. Now that we've tackled the theoretical concepts to build our technical skills, let's start playing with fire malware in brackets. Since we already assumed that the malware sample is written in C#, we will use DNSpy to decompile the binary and review its source code. DNSpy is an open source .NET assembly, C# debugger, and editor. It is typically used for reverse engineering .NET applications and analyzing their code, and it's primarily designed for examining and modifying .NET assemblies in a user-friendly, interactive way. It's also capable of modifying the retrieved source code, editing, setting breakpoints, or running through the code one step at a time, debugging. Now, let's talk accessibility. I don't know to what degree that all is accessible. The first glances I got at the app were not very promising. I saw the infamous .NET bug where you get a class name instead of the actual string in a list item, which is super common for .NET applications because Microsoft doesn't know how to accessibility by default. You can, however, there's also a DNSpy console version, and we saw that earlier. Did I ever move it back to the Chrome? Actually, let me pretty quickly check. Did I do that? I did not. Let me actually switch that back. Good thing that I read everything, isn't it? Hang on. There. So, this is what we're looking at. As mentioned above, we won't execute the malware. I'll actually go back to that diagram real quick so people can see it. There it is. That's where my mouse is. Basically, DNSpy, not super accessible. I actually am looking into maybe making that better. But not the original fork, because the original fork seems to have been abandoned since 2020. So if you want to do this by yourself, you have to download the DNSpy-ex off GitHub. Find this pretty easy to find if you Google that particular phrase. And then, yeah, you can use the console command to literally just get the output, all the code in the assembly in a folder. And you can just go through it with whatever tool you want, VS Code, Visual Studio Community, if that's what you want to do. There's probably things in there that are not valid C# code, so I don't think you can debug that way. But if you're just doing static analysis, you're not going to run the file and you're not intending to like modify stuff in memory and just want to look at the source code, this will work fine for like most of what you want to do, I'm pretty sure. So that is a workaround if the GUI is not very accessible. Honestly, reverse engineering is a bit of a new topic to me as well. So I don't know too many things about the tools that you can use. I know there's Radare or Radar, not sure how to pronounce that, but that is a command line tool that works pretty well. I played briefly with Ghidra, which was okay, but I don't think that does .NET specifically, but it does a couple of reverse engineering things. So there is certainly things you can do if this doesn't work. In this case, I would recommend, honestly, if they gave us the file, what I would probably do is I would run this through the console version and just open it up in a code editor, VS Code probably, because it's only one file, it looks like. Program.cs, like it's all stuck in one file. This Crunchyroll example I just gave is a lot of like dependencies. It makes it a little bit more annoying to find stuff in, but this thing, Super simple. So yeah, that's probably what I would do in this case. And for the rest, yeah, it's basically just a whole walkthrough of the entire code of this thing, which we can't see because it's locked in a VM that we can't access. So I could go through it all, but there's not really any point of doing that. Not for this particular video and the goal I have with it. So I'm not going to be doing that. What I am going to do, though, is make sure you don't run into barriers if you happen to be blind yourself and you can't do this task. So we're jumping down to the questions. Like I described, there is a piece of malware that's talking to a couple of URLs to get its instructions from. So there's one to just sort of indicate where it is. That's like a /reg endpoint. And then there is a /tasks that holds the instructions for the malware, where an attacker can put a bit of text that essentially gets parsed and decrypted by the malware to figure out what it's meant to be doing. That's really all the background you need to do these questions. The first question, I'm not going to read out loud because it wouldn't do you much good. What HTTP user agent was used by the malware for its connection requests to the C2 server? I'm going to put that answer in the video description because it's very long and very precise. It starts with Mozilla /5.0 bracket Macintosh semicolon Intel macOS 14.0 right bracket AppleWebKit /605.1.15. On and on and on it goes. It's quite long. So that's going to be in the description if you need that answer. The other ones I will read out because they're quite a bit shorter. What is the HTTP method used to submit the command execution output? So when the /tasks endpoint tells the malware to go do a command on the shell, it does a command with a hidden window so you can't see the execution, and then it stores the standard output of the command and sends that along to the server. So that is a way to exfiltrate the data that's being mined or collected, or just to get a response of what the attacker intended to do so they can see if their nefarious plot actually worked. To send something over the wire like that on HTTP protocol, you generally want to use POST, which is what the answer is for this one. So just, yeah, POST. POST. What key is used by malware to encrypt and decrypt the C2 data? So that is something you would not be able to figure out by yourself, because that's in one of the functions that is not in the code samples. The key is you can't hack this super secure C2 keys. All lowercase, no spaces, and there's no apostrophe between the N and the T in can. So you can't hack this super secure C2 keys. Keys, no Z's or any other weird leet speaks in there. Next. What is the first HTTP URL used by the malware? It is http://McGreedy secret c2.thm/reg or reg, R-E-G. Very similar to the URL we found yesterday in the FTK imager task. How many seconds is the hard-coded value used by the sleep function? And this you can find out. This is in one of the code samples that are on the page that show off the various functions in the program. It's 15,000 milliseconds, and milli means 1,000. So if you divide that by 1,000, you get 15, which means 15 seconds, and that's the right answer. Next one. What is the C2 command the attacker uses to execute commands via cmd.exe? So this is also in the text. You can guess this. In the main function of the software, and I'm doing this from memory. This is how I sort of learn how programs work. In the main function of the malware, so in the main entry point, there is a bunch of if statements that check a string for a certain keyword, and the keyword we're looking for, there's like implants to download more malware, there's sleep, there is a couple of other ones. I think there's quit to turn it off entirely, and then the one we want is actually shell for shell command. So SHELL, no strange study business or extra characters. That's just the word shell. What is the domain used by the malware to download another binary? Yeah, that's happening in the implant function. It's downloading a thing called spykit.exe. I'm mentioning that in case that gets relevant later. I don't know. It might. And the URL for that is stash.mcgreedy.thm. So McGreedy is McGreedy, MacGreedy. Check out the malware analysis module in the SOC level 2 path if you enjoyed analyzing malware. That's just a question with no answer. You just press the button and that ends this task. I'm actually finding it interesting to see how many times they've mentioned that pathway. It's new, that learning path. I think the SOC level 2 pathway came out this year, maybe even in the last couple of months, and they're really, really wanting people to use it, looks like. So, yeah, go check that out if you're interested. This is pretty much the end of this video. I'm sorry it was so ranty. I actually took a few hours to cool off when I saw this task, because I really did get rather pissed. Particularly because it's so frustratingly small of an adjustment to make it work for everyone. You just want to go in there and reach in and just fix it, and you can because you don't have the credentials for it. But yeah, I'm hoping next tasks will be better. I'm assuming by the text that the last bit of the text basically indicates that they're going to be using this data to take revenge on McGreedy trying to mind control them, which is something we missed. So I guess that's happening now. I'm assuming we're gonna hack them back or something. Maybe some more red teaming stuff, which I'm hoping means more command line and more Metasploit and things like that. So that would be easier to do. Wouldn't surprise me if I have to like hack in the SSH server again like I did a couple days ago, but we'll see. For now, this is all we're doing. This is the task 9 video, day 9 video, and I hope this was helpful. Oh, I just realized that I didn't really use the speech much. Well, I guess I had enough to say, and the speech wasn't really helping much, so there we go. This was day 9 with a screen reader and without a screen, and this is me signing off. I'm gonna do something else. Have a good day, have a good weekend, see you tomorrow. Goodbye.